Hello there, creators. I hope that you all are doing well and your revision for Maths Paper 2 is coming along just fine. Right, so today we'll be doing analytical geometry and we'll be doing what you need to know in order to start doing analytical geometry questions. Right, so the first thing that you need to know when you are to approach analytical geometry questions is to know the distance or know how to calculate the distance between 2 points. Right. So it's very important knowing this, because at any time that you might be asked in analytical geometry to calculate the distance of a certain point or between 2 points, therefore you know what to do. So you know that the distance will be equals to the root into x2 minus x1 squared plus y2 minus y1 squared in this particular order. This will mean that if you're going to start with x2, therefore you should also start with y2. If you're going to start with x1, that means also here you should start with x1, but it should be in this order. Right, so the second thing that you need to know in order to approach analytical geometry questions would be the average gradient. So this one you've learned it ever since you started maths, so it should come as easy. So the average gradient, right, calculating m. So you must know that the average gradient, or m, will be equals to the change in y, which is y2 minus y1 over x2 minus x1. Right, so this is how you calculate your average gradient, which is also represented by m. Right, let's check the third thing that you need to know in order to approach analytical geometry questions, and that would be the coordinates of a midpoint. Right, so that would be the coordinates of a midpoint. So the coordinates of a midpoint, that would be x to y, the midpoint, which are the coordinates, would be equals to, now that would be equals to x1 plus x2 divided by 2 into y1 plus y2 all divided by 2. Right, so if you use this formula here, it will be much easier for you to get the midpoint. Right, so you just need to take the two coordinates at the first point, then you find the midpoint of that particular points that you're looking for. Right, so let's now go to the fourth thing that you need to know. So that would, you need to know the equation of a straight line. Right, so that will be the equation of a straight line. Right. Right, so the equation of a straight line is the basic thing that you know, which is y is equals to mx plus c. Now, what you need to know is that m represents your gradient that we calculated. So we already know how to calculate our gradient. Right, so going to the fifth thing that you need to know in analytical geometry would be the angle and understanding the angle of inclination. Right, so that would be angle of inclination. Right, so what you need to know about the angle of inclination here is that if, let's say, we have a Cartesian plane here, right, so this would be your y-axis and this would be your x-axis. Right, so you have a straight line here with a positive gradient. So you must know that we should be able to see the gradient of a straight line even before calculating the gradient. So here we can see that this is an increasing graph, therefore this is a graph with a positive gradient. Therefore, when you measure your angle of inclination, you start from your right hand side going this side. Right, so that would be your angle of inclination. There you want theta. So what you must know there is that if here the gradient is positive, so if m is greater than 0, then you should know that theta, theta is an acute, so is equals to an acute angle. So what is an acute angle? An acute angle is an angle that is smaller than 90 degrees. Right. So it's important to know those terms, acute angle, obtuse angles, because that is what they usually use these days to trick learners, because they are used to them putting restrictions, but now they use words like acute angles and obtuse angles. Right. So the angle of inclination again would be when you have a negative gradient, right? So in that case, you'd have this is the y-axis and this is the x-axis, right? This is the x-axis. So you'd have a gradient going in this direction, right? So when you measure from this side, this angle here, when you have a negative gradient, so if the gradient is less than 0, then theta is an obtuse angle. So what is an obtuse angle? An obtuse angle is an angle bigger than 90 degrees. Yes, so that is an angle that is bigger than 90 degrees, right? So it means that for you to get this part here, it will be an angle that is 90 degrees when the angle of inclination is to your left or you have a negative gradient, right? So again, what is another thing that you need to know for analytical geometry? That would be your parallel lines, right? So you must know that when you have parallel lines, right? So what you need to know about parallel lines is that if you have two parallel lines, and what you need to know about those parallel lines is that the gradient in each line, so M1 will be equals to M2. So if you are given or you are asked to calculate the equation and you are given one or the gradient of one line, then it would be easier for you to know that, oh, the other gradient of that line as well will also be equals to that particular gradient, so they will be equal. So at that point you will be having M and you'll be needing to calculate C, then find the equation, right? So we'll do past papers to show how do you do that, right? So the last thing that you need to know for your analytical geometry would be perpendicular lines, right? So that would be perpendicular lines, right? So what is special about perpendicular lines, right? So what you must know about perpendicular lines is that if you have lines that are perpendicular, meaning meeting at 90 degrees, that will mean that the gradient of one line multiplied by the gradient of the second line would be equals to -1. So that is given. So anytime you're given that lines are perpendicular, therefore you should assume or you should know instantly or make a conclusion to say that if you multiply those gradients, therefore they must be equals to -1. So obviously you'll be given the gradient of one thing there, therefore you'll have to calculate the other gradient. So that is simple, right? So one last bonus thing that you need to know when dealing with analytical geometry questions, that would be knowing the properties. So that would be knowing the properties of your polygons and your quadrilaterals right? So knowing those properties will help you to be able to attempt those questions, or it will make you know some instant values. For example, if we were to deal with a square, maybe they put a square there, usually let's say you are given a parallelogram. So if you know that, okay, this is a parallelogram ABCD, so obviously if you had been given this maybe length here to be √2, then you'd instantly know that this is also equals to √2, because you know that the opposite sides of a parallelogram are equal. So that's the type of things that you will be dealing with and what you need to know when you deal with your analytical geometry. So that is the end of our concept revision. Thank you.